Hey everybody, it's Jordan. Welcome to another Binary Ninja live stream. All right, I can take the headset off. I just want to make sure the audio was working first. Last week we had a little mic mishap, so I could hear myself. That's a good sign. Welcome. Glad to be back. Our second one of 2021, as opposed to what it claimed in the tweet last week. This is not the first one. A couple of small updates first before we dig into the usual stuff. First, we don't have any winners yet from my challenge for who can identify the outro and intro music. And so I wanted to give a little bit of a hint for those of you who've watched several of the streams. You may have remember I mentioned it before, so I'll give a couple different hints. So there's a little bit of an incentive to go back and check multiple. The hint for this week is poet. And it sounds weird, but I had to double check myself. I wasn't sure how to actually say that word. If you recognize that, that's your hint, poet. If you don't recognize it, we'll lose some more hints a little bit later on. I forget what I said the prize was going to be in that. I'll have to actually go back and double check on that. But if we don't get any takers after a while, we might just keep kind of upping it. Something from the Binary Ninja store, or maybe we'll get all the way up to a free Binary Ninja license to anybody that can recognize where those come from. So anyway, what else do we got on the agenda? Oh, right. So we've got some good news. We're announcing, and let me flip over to the desktop. Control Shift Enter. There we go. Let's try it again. If I can remember my hotkeys. All right. Binary Ninja. Students internship. Oh no, I'll have to remember what I typed. We'll figure it out if that's wrong. There we go. I got it right in the first try. We are announcing, and we'll be tweeting about this a little bit later as well, and queuing up some reminders. But we're announcing our internship program for 2021. We have had an internship program for, I guess, 3 or 4 years now. This will be our 4th year, I think. It's been super successful. We've been very happy with it. Obviously, last year with COVID, things got a little crazy, and we had to kind of readjust to remote interns. So this year, we're going into the year knowing that that's the plan. So our summer internship plans for this year are expected to be remote. Actually, come to think of it, I need to update that page and make sure we note that. So if you are interested in internship or know somebody who might be, please send them to this page. And like I said, we'll be adding it to our tweets, and maybe we'll even replace our little title bar up there with a reference to this. But the details are there. The short summary is send your resume over to jobs@vector35.com. And we'd love to have, we've had fantastic applicants every year. Honestly, we get really, really great applicants. So we're hoping to continue that trend. Next up, we have, all right, so the two main things on my agenda this week are going to be, I wanted to show SEC a little bit more. So I talked about in a previous week, somebody had asked for some more information on that, the shellcode compiler. So we're going to play with that a little bit. And then, where at all possible, I like to kind of preview new features that are coming down, and I like fumble with them live on camera because oftentimes I haven't even used them. So this week's new feature we're going to be testing out is the type cross-references commit. So this is a pretty big new feature that Shusheng has been working on, and this is basically, if you want to find cross-references to variable cross-references. So if you've got a variable that you want to check cross-references to it, not just like function calls, but like you're referencing a variable. Or wait, is it type cross-references? I forget. I'm off. One of the rest of the Vector35 will probably straighten me out. That'll be our second main topic of that. And as always, I'm happy to have questions. So if you're in the chat, say hello and let me know you're there. And if you got anything you want to talk about as well, love to cover other topics too. So we'll jump into these and we'll see. This is where I'm going to put the test one. So actually, let's get this one ready. I just dropped it in. I don't even know which one that one was. 220, 73 looks like the test build here. So, all right. So here's gonna be the one we're gonna be doing later, but first we'll start with a regular binary ninja, and we'll get that one going. Is anybody there? Is nobody in chat yet? I just want to make sure my chat monitor's working. Say hi, folks. All right. Well, I can see my own message. I guess we have a quiet audience, or maybe I need to earn your feedback with something interesting. So first, let's talk about what SCC is, and one helpful way to get a little bit of info on it is to check in the help menu, which actually describes it. So if you, that's right, it's going to go in my browser tab. So if you click in the help menu, it'll open your offline docs. You can also always go to scc.binary.ninja. It doesn't matter so much. Oh, there we go. There's all the chat. Nice. We got several folks. Thanks for chiming in. Nice. Well, listen, hey, Castleton, if you guys are going to be just sitting here, like, this is supposed to be interactive. I mean, I know it's not Twitch where I can play games with y'all, and not quite that much, but awesome. Thanks for everybody chiming in. So the shellcode compiler came. The other thing I was going to mention real quick, the website, right? So there's the live one, there's the offline one. They're going to be the same content. At least I think they should be for these two. But much like there's also a help menu with API help, where you can check the Python reference and get your offline version of those docs, as well as the online ones at API. Those do occasionally diverge. So the reason that those would be different is if you were running a dev build and there's been commits since the last stable, because the public website only tracks stable. So in fact, this came up, I think, just recently. Somebody, maybe it was Fuzzle, or I forget exactly who it was asking about a particular API. And I went to go link, because I knew that like there was documentation on that API. I went to go link to it, and it wasn't on the public one because it was only on dev. So like when that happens, I'll usually just go like find the actual Python that's in GitHub and link to the PyDoc in there, and that'll work. But just as a heads up, to something to remember. But the nice thing is, whatever build you have offline, you've got the docs for you there as well. So shellcode compiler got started. I don't think it even says here as a bit of, it was a CTF tool. And so in fact, even Binary Ninja has some of its early, very, very early origins as a CTF tool. And so this was built because we were playing CTFs, and as often is the case, you want to build little shellcode payloads, so you don't, like, even getting a minimally, like if you want to get one of the like minimal libcs and get your compiler settings and kind of rip out stuff where you're not doing a full file, but you just got little snippets of position independent shellcode that you're going to drop into an exploit payload. It's a little bit of a pain to use traditional compilers. So shellcode compiler started from that, and then it's kind of in some ways grown into a little bit of a life of its own. There is, if you actually, we're over here on the GitHub, we've got issues that are tagged for SCC. So the one big caveat that I will mention off the bat, and some of you all will probably be familiar with this. Where is SCC? Oh, I think it's spelled out as a shellcode. It's probably on page 2. Where did it go? I'm sure I just missed it. It's in here. Performance level question type shellcode. I don't see it. SCC. No, it is there. There we go. SCC. Okay. So there is a tag on GitHub for SCC specific issues. Unfortunately, SCC doesn't get a ton of love. It's not something that we tend to focus on as much. It was kind of something that we had, and we've polished up a little bit. We've done some fixes on over the last few years as we've been working on Binary Ninja, but it's just it doesn't get as much focus as some of the other features. If there's more interest, if people are upvoting issues, as always, if there's one of these that's really important to you, go to GitHub and upvote it. I'm not logged in on this box, so I can't do the emoji thumbs up. But we very regularly will sort by, actually that's a good way to do it too. Where is it? Yeah, sort by thumbs up is built right in to Binja. So if you want to see what the most upvoted feature requests for SCC are, and that one has 0 of us, like literally none of these do, so that was sort of because it's kind of useless. You can take off that label and you can just see it in general. So like these are the general top, structure and type cross-references. Yeah, it wasn't variable cross-reference, it was type cross-references. And what a coincidence, this is the current #1 issue. So this is the feature we're going to be looking at later. Again, you can see like these are the things that people are voting on, and we use these a lot when we're doing kind of our version release planning. All right, so where was I? I tend to bounce around a lot. Right, so we're looking at SCC issues. I was talking about it hasn't been updated a whole lot. That said, SCC, it's kind of like a little bit of a hidden gem, because I think a lot of people will use Binary Ninja, never even know it's there. And then they'll see some kind of weird reference to it, or it'll be like, wait, what? There's a compiler? Like, what's this for? And so again, originally it was for capture the flag binaries, but there's a number of like really useful things that you can do with it. So first, I think the examples page is probably the most useful thing. There's not much to it, but just a couple little examples, mostly because I am a pretty terrible C programmer. Like I don't fluently just pump out C, so I try to avoid doing that on stream. If I can help it. So I can take one of these payloads, and we'll actually use Binja. So a couple different ways you can sort of access it. I'm just gonna hit Control N and make a new empty kind of file, and from here I can either edit and compile C source, or obviously I can hit the hotkey there. I can of course hit Control P in the command palette. And you notice SCC has the SCC reference, but if I just do compile, it'll get me the compile C source code. All right, and so I'm going to paste that as some source code in there. But let's look at just the basic UI here. We've got all the architectures that are supported by SCC, which is not necessarily the exact same architectures that Binary Ninja supports. SCC is implemented sort of separately. It's just a standalone binary that we ship with it. So it's not using like the ILs. One of our kind of interesting like long-term goals would be, wouldn't it be fun if we had a reason to either consolidate the ILs so we could use BNIL during CodeGen maybe. It wasn't really built for that, but it's an interesting idea. It might be a fun experiment. I don't know that we'll get around to it anytime soon, but it's a possibility. It could happen. But in the meantime, it still has a pretty good selection of architectures. In fact, during when was it? This was one of the legit BS years of DEF CON CTF finals, when they had a bunch of architectures, right? They had ARM and MIPS, and they had like an ARM embedded Windows, I think even. Was it the Windows Home or whatever the Windows ARM was at the time? There was several different like architectures. So they were kind of going for, I think, it was the year before Clement's year, before the CGC, or one of the two. And so like, I remember they had all sorts of fun, like literally juggling all the different hardware that they were doing to host the game. It was a lot of challenge, but every single target that they had, SCC had a payload. So I know that several people were like, it was really nice to have SCC just into Binja, and I was building my shellcode payloads on the fly for all the different exploits that we were writing, just what was already there. So because it's self-contained, it's really easy to use, it's got its own built-in minimal libc. And it has support for all of these. So again, at the time, you could be like, yeah, I want to build for Windows and ARM. And it's like, no problem. That would theoretically work. In fact, let's do it. Oh, yeah. So interactive bash obviously won't work on Windows, but like message box A. So let's pull that. And if I can remember not to hit Command C, but Control C, that would be helpful. So if you actually take like a Windows thing and say compile for ARM, like, okay, there you go, right? Like you're going to compile Windows ARM. So that's the one kind of way to access SCC. Just use the dialog. And while we're at it, let's look into here, because there's a couple of interesting options. And this again kind of goes back to the origin of SCC as a CTF tool, was that you would be able to like obfuscate your payload, right? So here, yeah, this is a good example. That was just our standard. This is a message box A on ARM and Windows. Why not actually just verify that? Let's go look at ARM v7 on Windows and look at the disassembly, and let's actually look at high-level IL. So this is going to be not super useful probably at high-level IL because this is going to do things like resolve symbols to be able to get message box A. It's going to do like whatever the PEB scanning equivalent is, I guess, on ARM. I don't even know how that works. I have no idea how that's actually implemented. But again, because it's meant to be standalone, it's got to resolve all the functions that you want to call on the fly. And so actually, I would probably recognize it a little bit better if I were to do it in x86. So I'm going to redo that with that. We'll see it's about the same size. And we're going to analyze that as x86 for Windows. So there's a little get EIP stub here. And it's going to use that to get pointers to the rest of the... actually, why is it going to use that? Yeah, it's gonna get that pointer. Anyway, I don't know exactly how the how this one works, and I didn't see. I don't see it resolving the API, but I do know that this is going to be able to resolve message box A on its own. Like that's the functionality there. So that's a really nice feature, which if you're building Windows shellcodes is handy, although that's less common in a lot of CTFs, obviously. So here's our two different payloads. We got our ARM one, we got our x86 one. But the thing I also want to look at is, let's go back to Hex. And then that was x86. Let's just do a different. Let's now do, let's do it for ARM again. Well, let's do it on x86 because I have a better chance of understanding things. And let's look over here. There's certain assumptions it makes, but you can generate polymorphic code. So like, I want to generate different code than last time. Like, please generate me something else. And if we look over here, we should see, yep, sure enough, that's a different payload, right? So if you want to like change your shellcode payload every time you threw in a CTF, you could do that really easily with that option. So if somebody tries to fingerprint it, can't just do a static byte match, which is really handy. And it literally comes with a checkbox, so it's pretty trivial to enable. How do you want to terminate? Do you care about it? Are you going to implement it yourself? Anti-disassembly sequences. Oh, that's funny. I don't remember that feature at all, actually. So let's look at that. And let's leave it at the default frequency. You can even specify a seed for polymorph if you want, which might not be a bad idea if you were going to automate it. But let's have it generate anti-disassembly sequences and do that. Although you'll notice the payload changed, that was actually dangerous because the original payload was still there. So because when I say like go ahead and compile C code, it's going to just compile it and dump those raw bytes wherever my cursor is. So if I literally move it down here and do it again, it's just going to append those bytes into here, right? So it's not automatically going to replace what I've currently got. So I'm going to delete it all, then I'm going to compile it, and then I'm going to do that with anti-debugging. And then I'm curious to take a look at what their anti-debugging looks like. Although I will note, in the past, there have been some options that we had to trim out of that UI because they were... This is interesting. Yeah, this is either... Was this the original one? Let's see. So that looked like a hash, which might have been... I don't know what that was. So this presumably is either part of the polymorphism or it's part of anti-debug. Oh, yeah. So this looks like anti-debugging, or at least like anti-analysis. It says anti-debugging, didn't it? It looks to me more like just... Oh, anti-disassembly. No, that makes more sense. Yeah, I was going to say, that's not actually an anti-debugging technique. It's just a... these would be what are known as like opaque predicates, right? So the idea is that do some random math operation and then have a conditional split, but in advance one of these will never be taken. And it's actually going to go to like some other random location and generate these fake branches. In fact, I think, let's try this. We actually have a thing called the opaque predicate patch, which I haven't tried in a while. It was part of a blog post that Peter did a while ago that was exactly for these kinds of situations. And it shows off how Binary Ninja actually can tell you what the value of EAX is here. I think I have toolbars disabled. EAX is always 1, right? Binja actually knows this because of its constant value analysis. And so when it gets here, actually, if we even look, this is a good example where if I look at higher levels, we should see at medium level IL still there, but once we go to high level IL, that just disappears. It actually never shows you those code branches because Binja's like, yeah, I know it can't ever get there. Which is really nice, this sort of dead code elimination feature, but it also is something that is on our current to-do list to work on, because if your dead code elimination is a little too aggressive, you'll lose legitimate pieces of code that maybe could be reached for a variety of reasons. Your analysis is wrong, there's state being changed outside of the current function in like a threaded environment to some global variable that you're losing, or calling another function where you're not doing interprocedural data flow. So there are definitely reasons you can be incorrect on that. But when it works, it's super nice, right? So like we just went from this control flow graph to this, right? And that's much more than just the normal medium level IL to high level IL analysis. In fact, a good comparison would be, let's go look at this other binary that was medium. Yeah, this is the same one, isn't it? This is literally this. So this is the same binary in medium level IL without the disassembly obfuscation. So you can see, obviously, it's going to blow up the graph by adding in those opaque predicates. And there may be other things it's doing there too, but that's at least the first one that I saw. So, the nice thing is now, like, we can literally just go to high level IL and it gets optimized away. It's solved. Or I kind of want to see if, so let's go back to disassembly and see if I can spell. Did I install it? Let's try restarting it. Restart Binja. Close without saving, close without saving, close without saving. Let's make a new one. Let's compile this. We're going to have into disassembly is on. Oh, that's nice. Actually, I haven't noticed that before. That even shows you which settings you have on that are non-default. Right here. That's cool. Learn something new every day about your own product even. All going quiet. No questions? So again, let me know if you want me to cover more or less of this. Like I would like to do the things y'all want to do. So, and I'm trying to be, but I even moved my camera so my line of sight is closer to chat, just so I could be, it could be like, closer here. I want this to feel personal. I'm only somewhat joking. I did actually move it. I don't know if you can see the setup here, which, by the way, if you're ever doing any streaming, Tackform, TACKFORM, Thumbhat, no worries, welcome. I mean, one of the things I want to eventually start doing on this channel too is just doing like some really entry level, like using Binja to solve basic problem stuff. Like right now I've kind of been doing it more as like a topical, here's the latest things that are happening this week or features that I want to go into more detail for people that are regulars. But we get asked a lot about like, do you have any like just, welcome to Binja, like here's how to use basic features things too. So at some point I'll probably get some basic crack me's or basic reverse engineering challenges and solve them on stream, because I think that would be useful. Welcome, Chris Carpenter. How's it going? So like again, ask away if y'all have things that you want me to cover or even just questions, but it's nice to know you're there. So all right, we're compiling our little shellcode again. For Windows x86, we've got anti-disassembly on. Let's do that, and then we'll do another one where we'll turn anti-disassembly off, just again for comparison. It's kind of nice. And I could like be saving these databases, but it's just so like fast and easy that I don't even really bother. All right. Patch opaque predicates. Okay, so that plugin's installed. And let's look. You'll notice again, this graph is actually different than the last time, right? Which makes sense because this is the opaque predicate one, right? Yeah, so this is the simpler one. Yep, it changed. It only has fewer little these opaque blocks there, it looks like, but we should be able to make them go away by doing that. Hey, very nice. In fact, now if we compare it, very cool, right? So all those opaque predicates are basically just patched out. And you'll see if you look closely, right, they're just knopped. So like the code that generated the opaque values and yeah, I mean, don't feel like you like have to play a CTF either. I just like CTF challenges because they're, I mean, one, that's kind of my background, and even though I play them less nowadays, it's a good community, but also because they tend to be like bite-sized stuff. Like a lot of reverse engineering tend to be really long-term, in-depth projects where you want to be, building up a database of analysis and building up your understanding of what's going on. And so CTF challenges tend to be smaller, which makes them a little bit better for, or things like Flare on, some of the earlier challenges before they start to get too hard, are really nice, quick things to sort of cover. Just because you can do them in a stream. I don't want to get too bogged down in super like long-term stuff on the stream, but we'll see what people want. Ooh, Nanta Tetris. Oh, that's cool. I think I'm trying to remember if I've heard that or not. I mean, I assume from the name, it's like here's the basic inch like building blocks to build a CPU and build a Tetris implementation. That's pretty cool. Yeah, we could take a look at the Hexagon plugin if we have time. Like I said, I want to get through SEC and, but I think we should. Like, I don't think especially it depends on how much, how easy of a time I have figuring out the type cross references plugin, but that could go easy. That's a good suggestion. Thanks, Levin. Oh man, C++ type databases. I would love to see that too. I am not the right person to do that, but I would love to bring on somebody else and like collaboratively mark up some C++ virtual function tables and structures and classes to do all that. Because I think it's not a strength of Binger right now. I wish it was. It's something that we want to work on more. To like there's a lot of plugins on, you can add on top of IDA. There's a couple on Binja as well. I know Josh Watson did one a while ago too, to like recover structures and function tables. But yeah, it is. I mean, Levin, the short answer is it totally is. It is painful to reverse engineer C++, even with the best tools, and like this stuff can still be hard. But yeah, I would love to have somebody on the stream to do that. It will not be me. I promise you that you will not see me reversing C++ on stream because I am bad at it. But that's a great idea. Let me make a note real quick. Oh man, can y'all help me remember? Anybody who's around at the beginning of the stream? I wrote a note over here that I can't even read. Remote? What do I mean by that? I was gonna do something. Oh, I was gonna update the intern page that it was remote. Yeah, see, I need to write more verbose notes to myself. Okay, and C++ walkthrough. Yeah, good idea. I have seen some names in the chats, I think, here who might be pretty good at doing a walkthrough if we can convince any of them to join us on stream. Yeah, no, multiple inheritance. I don't think there are any tools that are really good at C++ right now. I think there are some plugins that make IDA and Ghidra better at it. But again, I'm not a good C++ reverser, so I'm kind of going on secondhand knowledge at that point. So other people may have more insight. Yeah, it's a good idea though for a topic to cover. But or maybe we'll have to do one of our like feature sort of sprints in Binja where we're building out some new capabilities and testing it ourselves, and then we show it off. That might make for a better stream, but or even do it before and after. So yeah, so you can see with just a couple of like nops basically on things and turning your jumps into unconditional numps, you can improve that work, that analysis again, or even in the original. I can just undo that. I can switch over to high level IL, right, and you're gonna get the same sort of simplification because high level IL already has that dead code elimination. All right, so that's just a couple of the features in SCC. I mentioned there used to be more, so we really got ambitious, and Rusty did I think all of SCC. He's written a lot of that. Almost all of the earliest Binja code and SEC. There is a few more things though, which if you pop over in, where did I put, there it is. I think it's just here. No, it's plugins SCC. Yeah, so it's actually just a command line tool, and so even the UI just shells out to it essentially to generate its payloads, dumps it to a temp file, and then pulls it back in. So you can see this list of features is a lie. It does not support all of these features. These were sort of like the plan of like all the features that Rusty wanted to implement. Like one of my favorite would have been blacklisting. Like that'd be so cool to like just have like this automatic blacklisting compiler. So you could say like I've got an exploit payload, but I can never have spaces. I can't have nulls. I can't have whatever like character you want to have. And instead of having to run your shellcode payload through a whole separate encoder, just have the compiler know enough sort of synonyms and ways to change things so that it could do that, which would not be a trivial thing, but would be pretty cool. Yeah, no, like Chris, we've got that on the radar. Like C++ is on the list of like sort of like big we'll call them like stories or whatever, I guess, but just yeah, like big topics that we wanna take a concentrated look at and improve both UI around it, analysis around it. It's also possible that so one of the things now with high level IL that we're thinking about is we want to do a better job of like per language features. And instead of having like a totally separate compiler for Go or for Rust or for different languages, it would be nice. It would be nice if we could have like helpers for the existing high-level decompiler that make it more flexible for language, let people extend and add on to it. That might end up being related to the analysis pass stuff that's being worked on right now. It's one of the other kind of big cool features I'm looking forward to getting out. But yeah, language specific stuff would be neat. Yeah. Yeah, Marcus mentions that IDA 7.2 has basic inheritance instruction types. So yeah, and I was looking for an excuse to get Marcus on stream. So maybe you want to come and do some RE, even if it's some IDA reversing. You can show us what features you'd want built into Vidya. We can talk about them. Maybe we'll see. I don't know if I lose the other Vector 35 people may take away my stream creds if I let somebody stream IDA on here. Not now, he says. Yeah. Okay. Cool. So, like I said, not all of these actually work, but you can see a lot of them align with those options that we were looking at in the UI. How we exit out. I think. Hold on. That's one that I think actually works that the UI doesn't show. I think we removed. Maybe there was some bugs. I think there was some bugs on a certain platform. But I think in some cases, yeah, if memory serves, you can. Oh, that's cool. Does Markov chain actually work? I mean, like, again, some of these might actually work even if they're not in the UI, so you're welcome to kind of play around with it. But there was a ability to set the stack. Yeah, stack reg. This one I know works because we've actually used this to build CTF challenges before. So you can specify, I don't want to use RSP, ESP for my stack register. I want to use EDX as my stack register. And obviously it won't be calls and returns and pushes and pops. It'll be moves and subs and adds, but like you could build a stack with a piece of memory in any other register, right? And implement that on any architecture with different instructions. And it makes analysis, super annoying when you generate code like that. There's lots of ways you can frustrate program analysis tools. And so there's a couple of them kind of built into there. Anyway, that's a little bit more detail on SCC. I think is there anything else I wanted to cover on it? We can look at the runtime library. Just to get a sense for what like the libc sort of functions you've got built in. And again, there's some in here that are like really handy. They're not really like I think the connect back one is, or yeah, RC4 encryption, like really basic encryption implementation. So if you want to build a basic, backdoor for your exploit on a CTF, you could build it out with something like that. And again, you get cross-platform support, you get small payloads, you get a lot of little features kind of out of the gate. That's right, the last one, and I think I mentioned this as a bunch of devs. I need to move my headphones so I stop hearing myself. I think no underscore. I think I even tweeted about this recently, but there is, or well, not that recently. I guess it must have been a while ago. There is an architecture called Quark that's built into SCC. And it is a toy architecture that Rusty built a while ago. There we go. Oh yeah, how many people said that they were with zombies here on this survey? 50 of them was 5%. So more people than are truthful said they're with zombies, but maybe they did actually know about Quark. If they're not former Vector 35 people or former CTF teammates, I'd be surprised if there was anybody else. But another good reason to be covering this too is, if you look at this survey, a quarter of the people are like, what is SCC? Literally didn't know that there's a compiler built into Binary Ninja. But this one though, the Quark exec is really interesting. So this, I think I have the same one up over here. Yeah, Quark exec is execute a block of Quark code, right? So it's just a little simple virtual machine, but you can actually, we could make so we can compile some source, implement some algorithm. Is there any other better examples we want? Yeah, I mean, let's see. I don't know if Quark has file IO implemented in it, but oh right, so it's not the UI, right? So there's no UI for generating Quark, but I think if we, let's see what the syntax was again. Input files, all right. So SCC and Arch, I assume Arch is architecture. And I think if we just say Quark, there we go. So we can actually, is like a little undocumented architecture that SCC can generate for, right? So we can generate this Quark, there's no disassembler for this. We don't even have an internal Binary Ninja architecture for it, although we've toyed with making one. We really probably should as another simple example one. Or maybe we won't as an exercise to the reader, so you all can still use this. But this was actually used in a CTF challenge from many, many years ago, just as a real quick and dirty obfuscation technique, because there's also the Quark virtual machine. So there is a full VM built into SCC. So you can, Quark exec, right? So if you actually pass in, so I could grab this buffer, and actually let's try this real quick. So I can, in this little couple of things here, from hex dump. So this is paste from hex dump, right? So that was already formatted as a hex dump, which is another nifty little Binja superpower. And so I can literally just copy that, and Binja will actually extract out just the bytes, turn it back into the raw bytes, which is kind of a cool. There's like a lot of really useful paste from, copy as, and transform APIs. And in fact, one of the also lesser known features is that you can make your own. You can actually have your own transforms that you can extend and add on. And I think we've been meaning to have like a plugin contest style thing where we announce, like, because transforms are really, really easy to write. Like what's a useful transform that you might want to do to kind of like slice and dice some data. You can see there's a lot of encryption, encoding, decryption, hashing. But so like I can select the bytes and get a hash of it. Transform it in place, or just copy as, like, I want to copy the hash of that string. Or maybe, let's see, transform it, and we're going to encrypt it with whatever implementation you want, right? AES-56, put in your key. Probably has to be the right size, and I don't, how big is 120? No, it said it was 256 bits, right? So, yeah, I got it wrong. Anyway, you can put in the key, and oh, there's a really yappy dog walking by. I wonder if y'all can hear that. That's funny. Is the dog audible? I wonder. I've tried to play with the gain rate, but we've pasted this Quark value. We've got Quark shellcode. Actually didn't really want it in here. What I really want to do is take it and, well, I can actually then, let's copy this out back as, let's actually do that. Copy as a C array of 8-bit elements. And right, we can actually paste it right in. Right, so now I've got my, Quark payload. And then I could, where'd it go? Where'd it go? Where'd it go? Where'd it go? There it went. Quark exec, and it's going to be a no return function. So Quark exec Quark. I probably need to like make that a pointer or something because I'm really bad at C. Don't laugh at me. Don't laugh at me, internet. I know you're laughing. Thumbhat, that's a good question. Thumbhat asked about the Apple M1 support. I think we tweeted about this maybe, but the short summary is runs great through Rosetta 2 out of the box. It's very fast and peppy, as most things are. So like really well done on that, Apple. Good job. But it runs even better if you have a commercial license and can use it headlessly. So, for example, if you run Python 3, I'm on Linux on the van here. If I was on an M1 laptop, I can use the command line to basically, you can run either the M1 or the x64 emulated Python basically. And if you run the native M1 Python and import binary ninja, and do some analysis on it. Oh, I've got some plugin here on, don't I? Yeah, some plugin wants to do some analysis. You'll get native performance out of the M1, and it's blazing fast. Like for some workloads and some use cases, it was beating a Threadripper that we have around or have access to. That's obviously very, very quick with lots of cores, and the M1 was just super well performant on like a Mac Mini that we were running it on. We have like an M1 Mini. I mean, it is one nice feature of commercial Binja. We are looking forward to having it supported for all of the builds of Binja, but we're blocked currently on Qt support. And unfortunately, I don't know if I can find that Qt issue. Oh, I think I have it here. Let me pull up the link. But unfortunately, Qt has basically said, yeah, here it is. This is it. Sorry, no M1 support until 6.2. And they just released 6.0. So we've got 6.1, then 6.2 before they're going to officially support it. You can do it before then, and I noticed Ida even tweeted a screenshot of their UI running it. You can get Qt working on the M1 right now. You have to build it yourself. You can't use a lot of the plugins because you have to use Qt6. And then you have to sort of staple it and build the multi-binary support, or just have a separate installer. And so it's just a lot more logistical headache. And as much as I would love to have super blazing fast performance on the M1s, because it is pretty nice, what's the best use of our time? And just sort of waiting until Qt has actually got official support and has the prepackaged bundles and will do the stapling automatically. I think it just makes more sense. So that's our current plan. If Qt keeps taking like way too long, we might change our mind and go put the time into it. But until then, we'd rather just keep working on Binja features. And again, if performance really matters you're on an M1, yeah, you can get a commercial license. I wouldn't, it's not explicitly meant as an upsell. It just is the fact that our core has been ported for the M1 since 4 months now. Like we got about a week after we got the dev machine last year, before they were stable. So getting all of our code to work on it and compile for natively was straightforward. But again, Qt and PySide too as well, we got to wait on. So yep, good question. So I've got my source code, and did anyone correct me and say it's glaring wrong? Not yet, but let's actually, I think let's just Binja this up and compile for Linux x64. Quark exec not defined. Yeah, I might need to put the reference to it, and the extra parameters will be forward to the main. Oh, that's cool. Oh, that's what the parameters there are for. Yeah, that's nifty. So you can pass stuff in and out of it, play with the VM. All right, let's see if people, yeah, so Levin, I'm looking forward to collab as well, and not just because it's the most expensive version of Ninja ever. You know, I mean, it's been on our radar for a long time. We literally from the very beginning knew that collaboration was one of the features that we wanted to focus on and to kind of get right. And so, yeah, I'm super looking forward to getting out. And I think, you know, so just to clarify for other people that didn't hear it, the plan is to have collaboration be, it'll be a part of the enterprise server. So we have an enterprise version of Binary Ninja, which has floating licenses and collaboration with a server built in. It can work offline. It can even do like update management offline. We have some other features that will probably be coming post, like after the first release. I think it would be cool to do some sort of remote analysis, but that would be a big refactor. So that probably won't be coming anytime soon. But I think it'd be really cool to, you know, open up a really big binary and have it essentially spread out through all of the machines connected to the collaboration server. But not at launch. That will not be a launch feature. There's some extra logging, and you also are probably going to get like the cloud version of Binary Ninja, the web view, built into the collaboration server. So even if you don't have a license, like you're on your corporate network, you can pop open the browser and actually explore the binary using Cloud Ninja in your instance, essentially. So there's some really cool cool stuff coming with that. But you know, we always really want to try to do our best to make things available to like students and hobbyists. That's why we have our student discount. It's why we have the feature sort of split that we do, and that we continue to try to roll things from the commercial edition into the personal one. So we want to set up a public collab server essentially to let people that are playing CTFs or working on like not sensitive stuff use collaboration without having an enterprise collaboration server. So that's the current plan. But no ETA for sure on that. It'll be likely middle of the year, if not a little bit later. We'll see. We are just starting to like do early alpha testing of the collaboration server and clients. So it's done, but like we got, you know, testing. So depending on the work that comes, we may have more to do. Yeah, so enterprise will be, I think I answered your question 11 in my kind of stuff while I was chatting, but the long explanation is both commercial and non-commercial will be able to connect to the public, like CTF collaboration server. I don't even know what we're going to call it or what, you know, what features, limitations are, or exactly how it's going to work. We still haven't decided. And then we'll also have the enterprise server, which will include collaboration, include other features that'll be more for like, you know, again, teams that are doing this stuff like at big companies. And so yeah, that's the current plan. Looking forward to that. So yeah, I know. Again, I'm so bad at C, guys. Like, don't make fun of me. Do I need to declare that? Cork exec. Is it just because? No, because it said it couldn't find it before I had that, right? And that's a syntax error. On line 17. Oh, well, that's one problem. Yep, that was okay. So maybe that was right, and that was there, and I don't know about that. Pointers are hard, right? Invalid cast. Maybe I do need that. All right, I'm bad at computers. Sorry, guys. So if I wasn't so terrible at C, I'd have this working. But the short summary is can I resize this? Which hotkey? I don't remember. I need to practice with Regolith Linux a little bit more. I am happy that it's been a while since I had a tiling window management. It's been pretty good so far. Yeah, I don't see what I'm drawing. Anyway, if I wasn't broken, I'll figure out my bug after the stream, and I'll put a link to a guest or something in the description or tweet it or something. But yeah, you'd get like a full like VM based obfuscation essentially for whatever kind of payload you wanted to do, which would be much, much harder to analyze. And so, like I said, we literally made a CTF challenge many years ago that was just sort of like something like this, like build a Quark payload, run it through an emulator, and then put a couple of anti-debugging tricks on it and call it a challenge. It was a very lazy challenge in terms of making it for the effort that it took to solve it, but it's kind of cool that that's sort of built in. So that's the last little trick from, from SCC. All right, what else? There was one. What was the other question somebody asked about showing on stream? Might do that before we do. C++ discussion. What wasn't C++? There was something else I was talking about doing on stream. I don't remember which one it was. Yeah, so let's go check out the new type cross references. And so I guess for context, let's look at what we're trying to actually solve. Like, right? Like, what is the what is this feature supposed to be? And so you can see Wasamis has filed this 5 years ago. So this has been a long-standing bug. Oh, we didn't have an effort on this because I don't think we knew exactly how long it was going to take, but we're trying to get better about triaging our bugs. Oh, Hexagon, thank you. Yep. Yeah, and all I know about Hexagon is it's a crazy architecture. 4 years, am I bad at math? 2016, 2020, or 2021, but we're right in January versus it was December, so thank you. Yeah, just a little bit over 4. Oh man, stack view. Is it on this list? Come on, people, get to voting. Stack view, there it is. I mean, only a little bit more. Yeah. Yep. And actually, this one is not tagged for a milestone. So just a necro posting issues here, pulling them out. Yeah. I mean, in our defense, it took IDA like 20 years to add undo, right? A little more than that. So like, some of this stuff may be around for a while, even if people want it. Hopefully we don't take that long to get anything that people are asking about so much, but yeah, no, that one's been open for a bit. I think we've actually done a pretty good job. We just how we like as a company kind of prioritize stuff. No, so Joe, the idea behind the stack view is actually just in static analysis even. So there is actually a stack view for the debugger currently, but the debugger needs a little bit more love, which it's actually going to be getting. We've got the main developers who worked on that is going to be going back to that once he finishes up some of the ARM stuff he's working on now. And he'll kind of be taking another pass at debugger improvements. But there is a stack view in debugger, and we might even kind of use some of the UI design stuff out of that. But the idea is that when you're looking at like a function here, and you want to know like what's the stack layout, what's the usage of parameters and variables in this function look like. So I don't have an easy way to pull up IDA on stream or Ghidra, but if somebody else wants to link to a screenshot or something in the chat. The idea is that you can sort of get a sense of, I mean, so you've got like your function prototype up here, but this doesn't tell you how big things are necessarily. It doesn't show you local variables. I think if you hit space, yeah, so you sort of get some of that here, right? You get an idea of where things are at, but this is not a great view. It's not a great UI. You would really like something a little bit better. And in fact, let's go read that bug and see exactly how it's described. That's it. Yeah, but it will also be allowing you to manually edit it. So if you want to change it there, because you can't edit these currently. I guess you can change types, and so you could change sizes and stuff from there, but you can't directly like split things, for example. Like if you want to split one of these, you couldn't just easily do it through the UI. You'd have to do it by changing the type. And I don't even know if that's impossible at all. Actually, it may not even be. Oh, interesting. Yeah, I mean, it makes sense because you can edit them in a lot of the same ways. So you could make your stack view sort of a superset of or subset, depending on subset of your struct view, and use a lot of the same UI elements. Yep, so that one's been around. So the structure type cross-reference. So this one, though, is landing. This is, I've got a build here. We're going to test it out. And this one, the idea is that if you, yeah, I mean, the simplest explanation is if I've got a structure that's being used and I reverse engineer, I've created the structure, and I want to know where are all the places that this one particular member gets accessed, like where can I find them? Ooh, in fact, that's a good binary to grab. Where's the shapes one that Josh Watson had? It came up in Slack recently. See if I can find that and pull that into the VM real quick. Fun fact is forgotten, because that's the word I'm searching, because I remember I told Josh I had forgotten about that binary, so I'm trying to use that to find the binary. But is forgotten a compound word? Was a question my 7-year-old asked me today. And my wife and I immediately were like, no, like, yeah, for and got are like 2 words, but it's not actually, it doesn't necessarily mean it's a compound word, it's just a regular word. And he's like, Google says you're wrong. And I was like, wait, what? And he goes, you know, I'm not going to say it because I actually have one in the room, but you know, she's always listening. He says the wake word and says, is forgotten a compound word? And sure enough, comes up, it is. So I kind of looked into it a little bit more, and the short answer is, yeah, it is. It is actually a compound word. And it actually, in fact, kind of makes sense too when it's forgot and got and gotten, or forget. So it's get, and then the past tense is gotten, is why you go from forgot to forgotten, forget from forget to forgotten. Is that right? I think. Anyway. You know, so the split expression feature you're talking about, Marcus, is that for, like, you've got a variable being accessed and it thinks it's one big buffer, but you actually want to treat it separately? You're welcome for the English lesson. I don't know. Look, I was trying to stall while I looked for this binary, and I'm still looking for it. I got distracted. But yeah, you can chime in instead and explain more about the split expression. So the feature you're saying you use a lot of is a split expression meant for like an expression where you've got like multiple, you know, I think of like the IL or the Binja idea of an expression, right? Is like, you know, multiple IL statements grouped where if 5 is greater than this and this, like that's an expression. Or is it more of like splitting a structure, a reference from a variable into multiple pieces? Which is it? Where is that file? Polygon? How do I find it? I bet I can get it in the trail of bits. Ah, there we go. Polygon found it. So Robin posted it. vtable navigator as a quick example. We may try that and see if we get some of these variable cross-references working. Marcus didn't rise to my bait to answer the question more. That's all right. I'm the one on stream. He doesn't have to answer any questions. So why did I just paste that? No, not that one. Copy. I will say, Marcus, I am much rather have people who chime in at all than people who don't. So take my harassment with the love that's intended. All right, so let's build. Right, because it's .c. Okay, so we've built this polygon binary. I called it the polygon binary. It has a couple of basic classes and structs. Oh, right, hold on, I gotta switch. Gotta do it with my new build. All right, so switch to my screen in time. Open my binary. All right. So actually, yeah, no, let's go back to making the cross references a little bit bigger because that should be the star of the show here once we get this kind of set up. Okay, so this one does have. All right, we haven't stripped anything, so we've got symbols, but let's go to like the types view. And I'm going to cheat and pull it out because we know what the types are here. So we had the source for it in another window. Okay, splitting a variable. Yeah. Yeah. Into 2D words. Right. So that makes sense then. Yeah, I'm familiar with that concept, although I haven't used it. Again, I'm bad at reverse engineering. I like playing with the Python stuff. All right, let's take, where did I go? Come on. Oh, I gotta remember to, I have to remember my hotkeys are switching back when I go on my native Mac. All right, let's just grab this. Let's open up. All right. So let's insert, oh, this is, yes. So struct polygon packed. Except this is a fun quirk. I could probably forward declare these because they're referential. Struct polygon table packed. Let's try that. I did it a different way last time, and I want to see if this is the right way to do it. Right. So, and thanks to Josh Watson, I haven't seen him on stream. I don't know if he's here or not. For a nice little sample program. He sometimes drops in. All right, so let's have struct polygon vtable. Yeah, all right, that worked. Good. I did some bad things last time I did that. Anyway, now we've got our two structures. Let's go apply them. So if we go back to where was our source code again? I'm cheating and skipping all the actual reverse engineering. I told you I'm not going to reverse engineer. Josh, I'm telling you, Josh is going to make a comeback. We're going to see Josh again. I have faith in Josh. I bet he's live again. I would love to see his streams again. Or maybe we'll just have him on as a guest. Maybe he couldn't do the full stream, but he wants to come and hang out for a little bit. We'll be happy to have him. I do need to set up my streaming a little bit better. All right, so where am I going? Source code for, yeah, here it is. All right. So print, yeah, we should just take print area. You notice this is one interesting side effect. So because we've actually got the debug symbol, or we got the symbols in the original binary, we know that it had a polygon pointer it takes. However, when the binary is analyzed and we pull out that string, that's just like a string essentially. We don't actually have that type information. We didn't have the dwarf information loaded into Binja. Although we might have, if well, I don't know what the default is for GCC. I don't know if it includes dwarf by default, but if we did add dwarf, we could use the new dwarf plugin to actually pull the type information directly, and then I wouldn't have had to make those types at all. They would have already been in there. But you'll until if you don't have dwarf information, but you still have symbols, you'll see stuff like that where it is sort of like a mismatch between what this says and what this says. But we can just fix this especially now that we have that type. And actually, was it this is print area as a void? It was not an int. Void print area. Gone. Call it poly. Just like the original. And boom! Oh, we've got much prettier references now that we're looking at. So I mean, yeah, I don't know. That's a good question, Chris. Also, do you prefer Christopher or Chris? I see full names sometimes for people on YouTube. I never know, but yeah. I mean, my guess is we probably would just implement like that to me sounds like something that I would badger somebody to help me build a little GIST snippet and throw in the snippet plugin manager to execute, to pull out some of those types and create. I mean, the problem is, like, if you don't even know the structure size, you don't know any of the details on it, it's not really gonna do you a lot of good to do that, I don't think. I don't know. And again, I mean, that kind of starts getting into the, like, well, just better support for detecting that with C++ in the first place, because back to our other discussion. But in the meantime, if we supply stuff, we should have, okay, so let's see. I've got an area reference. This is code references. Hold on now, I want to get the, so let me check something real quick. Which build? I am on build 2173. Build 2173 should be the build that comes off of our CI that's testing, that we do our test builds on. So we're working on features that are really like early, or we want other Vector35 people to take a look at it. We'll commit it to a test branch. Those get put into a separate test build channel. And so that's what I'm on here. Hopefully, if this feature works well, we'll be rolling it out soon to everybody on dev, and you'll be able to test it too. So this is, yeah, so these are address code references, just code references. Okay. So I've got code. Oh, hold on. Let me go to the type view. Right. What? There was type references. There it is. All right. So all that just to set that up. But yeah. Do we have any Polygon? We should have. I don't see Polygon references. Well, let me say I see like the code references, but where is? It's the only one I see is the type reference from the Polygon. I guess so. This is just in. Is that intentionally just showing the other types that reference it? Let me go back. Let's go read that bug and see what we're supposed to be looking at. Structure members can be cross-referenced to their use in a single function, but it includes the access type. Allows structure members to be cross-referenced across the entire database as well as including their access type. So read and write, I don't think is here at all. Well, hold on, maybe we can filter it. No. In and out is code references. It's not for type references. That's been there for a while. You can filter on that. And actually, this is a good question. Can you pin them and get the same ones? Yeah. Okay. Although in this case, the type reference doesn't really do anything useful because it's pointing at the polygon. It's pointing here, right? It's pointing at this is a reference from that. So I think I'm either missing more of what this thing does. So that's one bit of the new stuff, but I think there's more to it. Let me, just for kicks, print area, and let's fix up some of these too, just to see if we get more stuff. Okay, print sides. What else do we have in our original source? We had print sides, print area. Main does the things, which actually, if we go look at main, I've got our initializers. Yeah, that's a good question. So that's just it knows it's a type of poly. Variable references. Yeah, this is why I generally try to prepare a little bit better, but this time I was running a little bit behind. Ah, okay, well that's a good question. So if we go back here, yes, that works. Does that not work in the current stable? Let's see. So if that's the difference, let's run our dev build. Oh, hold up. Let me save a BNDB real quick. Yeah. And I always do that. I need to remove bindiff from my list of recent stuff. I guess I could have just opened it directly too. All right, so do we have all our types still? Print area, yeah, we do. Okay, so if I currently go to the types view and find my polygon, we've got our code references. Does it not work? Oh, that works. I think that, I mean, that should be working just a minor. That's the point there, right? Like, unless it's the member references. Yeah, this one's still just the structure because the first one is the same offset. So there's no reference to the sides, but let's see, what about over here? Can you type here? No, you still can't filter on the type list. I think that's, yeah, the type view needs an overhaul. It's on the either 2.3 or 3.0 roadmap, I think. Well, that's obviously not what that one's referring to. All right, so let's go back to our, yeah, that's still just that one. We actually got more references here than that one. Although it is worth noting that this test build may be rebased off something else. Oh, when I picked this thing, was it called null? Oh, I see what you're saying. Right, that was the bug. That was exactly the bug. I got you. This here, this call RDX, is a call 0. So if I select anything else like this, I'm getting the same call RDX. Right, I got you. That is exactly the bug. Right. So this was the old behavior, right? Is that because this structure has the type view has this 0 offset, the fact that I had this print area would happen to call RDX, which the static analysis thinks is a null pointer because it's not calculating it through this presumably is being passed in. It just shows, yeah, you're calling that. It's clearly not. That's not what it's actually doing. And that's why in this one, we actually only see the real code reference. So yeah, there you go. All right, well, good. It's not anymore piston miner, or at least it won't be shortly. So I like it when you guys can help me figure out the new features. But yeah, that looks like that's the fix. Basically, you actually do get these code references are real now. They were bogus before. And so you've actually got references to the correct code references to the polygon, right? Which is exactly what the original bug was requesting. It was saying, if I've got this structure being used, where is it actually being used? And you can now see where all the different members of it are being used. Although I'm surprised we don't get any for width. I feel like we should be getting a reference for width, like under set value should do it. Yeah, that's what I'm looking. That's exactly what I'm thinking. Is why am I not seeing? Like, I want to be able to find where all the widths reference. So I was looking back in the original source, where, I mean, they're in like the constructors for, or like actually area will do it. Area will calculate it, right? Yeah. And it's going to, oh, yeah, this is not a good look for high level IL. Let's go back here. So, oh wait, which one am I on to? Right, make sure I'm still on let me actually close down the dev build so I don't accidentally flip back to it and forget. We're on the right branch. Yeah, so I did. I added the type on that print area and print sides, but I don't think that oh, this one here. I don't know. I warned you guys I'm not good at C++ reversing. I do see, so I think there's more. Yeah, like this should be. I'm really confused how that's calculating the width. Did it just get optimized away? But I don't see a, no, but the width for, no, it can't be. Both of these look very wrong and not what I expected. Yeah, like, I mean, you can see the exact syntax I did was literally just the default of, there's the build. So whatever the very, very defaults are, that's what we got. No, the weird thing is, like, area is not calculating area at all. Like, return 0 is correct. That is what this thing does. I don't know what it's doing. I mean, it writes into a local, yeah, it does nothing. It does nothing, and so the polygon size does nothing. Oh, area is down here. Okay, area does do this. All right. Maybe it helps if I look in the right function. Yeah, that actually looks like an area calculation now. And all right, there we go. So area needs to have its type set. So it's going to take this pointer to the polygon, right? Hey, all right, that looks better. All right. Yeah, I was looking at polygon area versus rectangle area. Okay. And actually, you know what? Go back and look at the source. That is exactly what it does. So this makes more sense. This is doing the right thing. Let's pull this up again over here. Yeah, the polygon really does just return 0. And I doubted Binja. That's just then the inherited rectangle is going to implement the real one, and triangles they're each going to implement their respective algorithms. In fact, yeah, like this is exactly right. Right, so Binja did exactly what we wanted, and we've got now. If we go to the types view, hey, there we go. We're seeing area calculations. Cool. All right. Well, yeah, piston miner. You and me. It's my first for reverse. Well, I've reversed a little bit of C++, but not if I can help it. I know what you meant though. You were saying like that's like the code example, and this is a very old example. That Josh built, I guess it was February 2017. I mean, that feels like a decade ago, right? I think we're allowed to say that now. Yeah, so it does what we expect, right? We're actually getting proper code references, and so if we've got, we could go fix up the rest of them. So if we've got this other, so there's area, rectangle sides, we can do triangle. Where's triangle? Triangle area. And it returns, yeah, it does actually. What does it return? Just an int, yeah, that works. This syntax is not so great. And that really could be better because it's just divided by 2. To answer your question, polygon is here. Rectangle, or yeah, I'm not a C++ dev. I'm not even gonna go any further than that. All right, I think that's so what time are we at? 6:20. All right, a little bit early, but yeah. So I think the key summarization for that is basically it's fixed. It was entirely broken before. Thanks for pointing that out, Piston Miner. Essentially, the way that the cross-reference system used to work was you selected something in the type view, and it would just literally use these addresses that were indexes into the structure, and it would try to find things that matched that. And what we instead can do now is we can actually do what you want to do, which is, yeah, this makes sense that this was the number one upvoted thing. If you're creating structures, you really want to see, oh wait, did area? Oh yeah, there we go. All right, so I added both the type triangle as well too. You'll now notice that triangle and rectangle both are producing these cross references. So yeah, Chris, so like that was the bug, right? The bug is it's like using this area and essentially displaying gibberish down here, and now it's actually showing proper cross references. So we're actually getting this. Does it work for enums? I don't know. That's a good question. I can look at the commit logs on that branch and see if anything pops out specifically. These are like, I mean, yes, that's part of the structure. But I don't, yeah, so that's interesting too. So it shows you not only, it'll show you cross references within other structures, it'll show you cross references to those structures as they're used in the code. And even just data, presumably too, if you actually, created a structure as some data variable. And actually we could do that probably if we want to pick something here. Let's find some random data. There's the names. Yeah, it does have like pointers in them though, so I'm not going to be able to arbitrarily like do that and get real data. But presumably, if we wanted to like append some data to one of these, oh, there we go. Those are view tables. We would also get cross references. Actually, wait, what section is this in? Yeah. Okay. So we would be getting, oh yeah, here it is. In fact, actually, yeah. So this is the elf-din structure. So we saw this in the enum. But the problem is, I think we saw it. So actually, let's do this. View, or no, window, split to new window. And then let's kill this. And I'm going to switch the types view. I don't remember hotkeys for resizing. That's fine. Let's go look at that enum. So I do need I need to show cross references. That's rather the point. Refer cross. Show cross references. Okay. So we've got references to yeah. Well, no, not. We're just seeing the whole thing, right? So looking at this. Actually, yeah, Joe, asking about official processor modules. We've talked about it. We don't have anything on the immediate radar. We're currently finishing up a sort of intensive deep dive into ARM that is really, really, really nice. We've had a lot of people in the community. If you saw last week, we give out awards for community contributions for the ones that we open sourced. But we were just talking about how it's been a while since we put out any new architectures. Our general philosophy is that we would rather focus on the core. There's a very long tail of architectures that people care about, and so you get like diminishing returns per arch past a certain point. So we think it has like better value just to produce better analysis or make writing architecture plugins easier or helping people that are working on specific ones. But we haven't ruled it out. We certainly are considering it. If you have suggestions, if I click on DT needed, yeah, I know. So if I click on, that's what I'm saying. If I click on these enum specifically, it does not look like it's supported piston miner. Right, because I'm seeing the cross references over here, they're not changing. I'm just seeing the whole enum itself. So you'll find every place that enum is used because they're all referenced here in this table here. Yeah, what you rather would see, right, is DT needed and then just see these references. but I think we're getting a lot more than that. Although let's check, make sure. Yeah, we're definitely getting everything. So that's a good feature enhancement for this one. In fact, if you want to go ahead and add a comment on that, like I said, there it is, bug 577. If you want to do it, and if it's kind of out of scope for the current plan, worst case, we'll split it out to a new feature when we close this one when it lands. But yeah, no, that's a good request. I think there's some other enum support that we might bundle up with whatever we make that an improvement. But yeah, that'll be nice. Yeah. So oh, Joe, RISC-V. Actually, we already have a RISC-V official supported plugin. It's just semi-public. We've got good results with it already. The reason it's not fully public is because it uses our Rust bindings, which Ryan, one of the Vector 35 guys who built the Rust bindings, didn't want to officially support. They weren't fully done, documentation. So he's like, yeah, I've got these things, they work. You can, in fact, I could even probably on stream grab the and build the plugin later and play with it. But the good news is, ironically, for the dwarf work that we're doing, we've actually got like a trend of more Rust in general that's been coming up. And so we're making the API. They're still not, the Rust APIs are still not as complete or as well documented as Python, but we're like, let's get something out. Something's better than nothing. So probably the next, I don't know, Kyle, don't hate me, next week or two, you might see a public commit of the Rust bindings as well as the dwarf plugin. So there's already a Python dwarf plugin that we've got that was a sort of based on some other work that some of our other guys were doing, that we pulled out into a separate plugin. So like if you look now in the plugin manager, there is a dwarf there's a dwarf plugin in here, and it parses out dwarf data, does a bunch of good work, but it's Python, it's slow, it's like after the effect. And so what was being worked on is a native plugin, so it's much faster, and also integrating it into the analysis pipeline, because as I even showed, right, like if you've got dwarf information, you want to do that when you first analyze the binary, because you know where all the functions are, you know where all the types are. Like, do that at first. Don't have Binary Ninja just go generate and try to find all the functions and then go apply all the dwarf information. That like doesn't make any sense. So that change is already done. It's just in testing, where basically it's now possible for you to plug in analysis stuff. Actually, I think this is what Kyle showed. Maybe was it last week on stream? I think he showed this. So if you go back to the videos in the description notes and all previous videos, there's links to the timestamps for all the different segments. So you should be able to get. You can go see the demo of that plugin. But there's probably also some more discussion about all the Rust stuff too. Thanks, Busted Miner. Yeah, so Joe, we've got basically the bindings. They're primarily focused on adding architectures and adding I think adding binary views might even be a part of it, but they're less focused on like for analysis plugins the way you're using Python right now to like do a bunch of queries across the ILs and do things like that's not where the Rust has been fleshed out as much. And I don't know the exact state of it lately. I haven't talked to those guys, so I'm curious myself what the state of it is. But yeah, we hope to get a release relatively soon. Kyle hasn't said anything, so either he's not watching or he doesn't want to commit or promise anything. But yeah, that'll be coming out soon. And then when we do that, we should actually be able to have the RISC-V plugin shipped by default and open sourced as well. You can get access to it right now if you want. So yeah, like those are the features that the current Rust APIs have, which means you can implement the architecture is fully working, right? Like you can get a native RISC-V analysis module right now for Binja. In fact, I'm trying to remember if you're in the Binja Slack or not. If you are, Joe, ping me on there. And I can add you to the channel, and we can add you to there's a GitLab right now that we've got. I mean, there's a couple dozen people in there. It's only not like fully public again, because we just want to be careful about like, this is an officially supported thing, because then, there's certain expectations for like quality and support. And so we want to, that's the only reason it's not fully public right now. But I can get you the RISC-V architecture stuff. And if you're already familiar with Rust, you can build it yourself and add it on even before we end up publishing the API. And I don't know that the RISC-V will necessarily come immediately with the APIs that Kyle's working on, because they're kind of separate. But yeah, definitely happy to give you access. Would love feedback on that. And I haven't looked at it in a while, but I think the analysis was pretty decent. Like there is another public RISC-V plugin. Oops, if I could spell. That's in here. And I think though that the analysis quality of this was not quite as good, and it was using it's using Capstone. I don't know how much lifting it was doing. It's written in Python, so I think that the results people were seeing with this was not as good. But it is cool to have a start there. So yeah, you'll get much better performance out of the native one. Yeah, that's a great question, Joe. So, you're asking about okay, it's a native plugin, but like, how does that work? A great example is Hexagon. Hexagon is currently in the community. Actually, it's not currently in the community repository for that exact reason. But a Google, CFIR, I don't know how to pronounce your first name. I apologize. He just joined the Slack recently. Published. Let's see if I can find it. Probably have pulled off of Twitter. There it is. Yeah, surprise, Google's SEO is really high for Google. So this is relatively new, week and a half old plugin that is a native plugin, right? So in this case, it's C++. Which is great for performance. And in fact, most architectures really should be implemented in either Rust or C++, not Python, unless it's just very tiny binaries, because the Python performance for handling all the callbacks is just really too slow. Although, again, our official 6502 disassembler is written in Python as an example for that architecture. But for performance reasons, definitely would recommend doing it one of the native ones. But yeah, there is no way currently to install this plugin via the plugin manager, and that's a definite thing that we're actively working on right now. One of the things that is in development right now for that is better versioning with the native APIs, so that we can query the status of the version of the native plugin before we load it. Almost all the native APIs now are ones that we're shipping, and so every new build, a new build of the plugin goes out, so it's not a big deal. But with community ones, you have to make sure that you're not running like an old incompatible one, and so we need to have a better API run versioning for the native plugins. And I think that's current, right now, literally what he's working on, or at least it's on his radar for a relatively soon thing. So I don't know that we're going to necessarily fully solve the ability to install native plugins via the plugin manager. But it's something we're thinking about, because the Hexagon one is a great example. I really want more people to know about this plugin, and we really try to make everything discoverable as much as possible through the plugin manager. So whether we have a separate plugin that maybe you can't install, but it just says manual installation only, I really do want to have some stopgap that just lets people find those native plugins, and then ultimately, the plan would be to have them to be installable. But that probably involves us setting up some parallel build infrastructure, and when we're kicking off new builds, building the plugins and testing them via minimally, and then installing them that way. But it's something that we want to do. In fact, one of our long-term goals is to actually have a paid app store kind of thing, where if somebody else wants to build some really esoteric architecture that we're not going to put the time in for, but a few people care a lot about it, and somebody wants to build it and then sell it, great, you can do that when we'll ship it and distribute it through the plugin manager and manage all the payments using our existing infrastructure. So it's kind of one of the things we thought would be nice to do long term. And so there's no real timeline on that, but to do that, we've basically got to do the building and vetting of plugins and stuff. So long answer to say, no, not right now. There's no easy way to do it. You just kind of got to build it, drop it in your plugin folder, and then rebuild it. But it's something that we want to do. We want to have a better solution on. Although I think that's generally the IDA way too, right? Or people put out releases for specific versions. If people want to put out native plugins tagged to specific stable releases, that'd be pretty easy. Do releases on GitHub, for example. So I'm not sure I understand the question, Chris. Why not have a Git dependency added and allow for pulling a repository? So that's exactly how the plugin manager currently works. The plugin manager currently is exactly that. When I download one of these, I can download or click install on annotate functions. What it's actually doing is Git cloning into my user folder. So there's the community plugin folder, and you can see bcurler annotate just got added here, and it's actually being pulled in via Git. We actually have it's doesn't have the .git folders for like versioning and stuff because we don't really want the extra things, but it is actually using the Git APIs to grab the latest release, pull it down, and pull it in. Yeah, it does. It basically does. It's not actually technically a pull, but it's like a Git or something. It uses Git currently to get that release already. So that's a great suggestion, which I'm gonna make a note of. But just that, like, change the install button to like fetch, for example, for native plugins, and then the build instructions. There's already build instructions, already a section of the help doc specifically for build instructions. And so not everybody uses it, but there's a whole like installation tab where you can describe in greater detail. That's a great idea. Fetch native. Yeah, thanks for the suggestion. And speaking of which, the Hexagon, so we're already touching on this, which we were talking about doing for the last thing on the stream. I don't think I'm gonna build it. I mean, if y'all really want me to do it, take me a little bit to clone the repo, get the build up. Well, and we can. Let's see. I don't know. Maybe we can do this if y'all are interested. We can go through it. Oops, that's not gonna work, is it? Yeah, we can go ahead and build this actually. Yes, Hexagon is one of those architectures with like weird stuff. I think there's also like a DSP essentially built into it too. I don't know. There's like it does a couple of strange things, which I think I have not tried this plugin, so I don't know. Oh no, y'all can do frequency analysis and figure out my stream VM password. I'm lazy. I don't usually do virtual EMs, especially on a VM that's snapshotted. I probably should do VMs, but yeah, I've heard there's some issues with it. But let's keep going. Build, make, see. Okay. Where'd it go? My terminal. I had a terminal. There's my terminal. Build. Really? All right. So let's see. And this, by the way, is why I have a separate machine from the stream machine that I can so I can build on it and not kill my cores. It's gonna need. Oh, it found binge core. Not building test binaries and using pre-built instead. Oh, if it comes with test binaries, that's cool. Test binaries, nice. Very nice. All right, I like it. All right, let's build that. Huh. So anybody that's interested in, thanks for that explanation, Parker, about how the instruction slots work. I don't really know the details of the architecture stuff. I'm, again, of the Binja devs, the least qualified to talk about weird architectures and how you would implement them. But if you are interested, there is a whole Hexagon channel in the Binary Ninja Slack just for people. So CFIR, who built this one, works at Google, and this has been their 20% time project for a couple months now, is in there. And there's a couple other people who've worked on various architecture plugins. So I know that there are several interested people. And Hexagon actually is a good example, Joe, when you're asking earlier about like ones we've considered like doing an official plugin for. We've thought about it. There's definitely interest. But Clang format not found. I mean, I wouldn't think that's a separate. Sure. Is that it? Is there any other requirements I missed that? That's cool. I like that it found the default install location. That's actually really nice. And then, yeah, this sim linking it in should be all we need to do at the end. So the headless tests require a commercial license, which makes sense. Cool. All right, let's try this again. Clang format is all you needed. All right, let's go. I'll have to file an issue on a separate machine. I'm not logged in to get here. So I apologize, Parker, for not recognizing hand. I know there were people in the Hexagon channel, and if you were the main one working on the other Hexagon plugin, good timing. Glad you're here. I know it's a little sad. You a little bit got sniped with this public plugin, but I don't know whether there's collaboration or hopefully we get two good plugins out of it. We'll see. I'm always happy to have people working on plugins, and that is one of the ways that we sort of judge what might be a good plugin to work on, Joe. And as we're thinking about architectures that we would implement, the other because we're doing all of our architectures as open source now, we don't have any private architectures. It's entirely possible we just start working with one of the community ones to provide better support for whatever that architecture is, and then eventually maybe it becomes mature enough that we ask, would you be willing to let us move it into the official ship repos and include it with the product as another option, especially where it's a native plugin and you've got to build it yourself otherwise, or if we can get it into our official workflow. So my guess is that's what we would end up doing, is either partnering with other people or working on an open source thing where other people might contribute to it if there's interest, and then we could ship it by default to extend out the different ones. But again, let us know when you've got other architectures. But yeah, good news is RISC-V is already done essentially, and should be coming out soon. So let's see if my build. I can't remember what I need to be more consistent about what things I put on what tab. I'm always flicking around. All right, it's built. So that wasn't it. I should just be able to do that. And let's see if we've got our plugin. Oh. Didn't like that. Okay. That's because this is the wrong version of Binja, right? So remember, it found at least I think that's why. Let's make sure. It found Binary Ninja at the default location, but that's not the build I was running. I was running the test build, which is a different one. Nope, something else, because this is the build that it was running. Cannot open shared object notes. Oh, hold on. Probably my symlink is just wrong. Let's just do it the old-fashioned way. First, Arch, Dev, Binja, Hexagon, build. Well, that's one problem. Yeah, that's why. Wow. Wait, build plugin, libarch. Okay. I'm still going to use the dev build and not the test build because there may be API differences, because I don't know how recently the rebasing had happened on that one. But all right, no errors. And let's open up. That was a pretty easy build. Kudos on that build process. That wasn't bad at all. Other than the Clang format, which I need to file an issue for after I get off stream. as a dependency. All right. So we're going to look at our dev folder, our binge Hexagon, test binaries, and thank you as well, by the way. Like including like a test binary for the architecture plugin makes my life as the app maintainer so much easier. It makes screenshots and plugins. So yeah, that's really, really helpful. I mean, okay. There we go. So that's how you would build the plugin. There may be a little bit of differences in how you would do that build on other platforms if you're not using Binge on Linux. But it looks like these are all just their test functions. Double direct jump. Yeah, so I guess this is handling a lot of the cases. Interesting. All right. Well, cool. Yeah, I'll leave. Oh, interesting. Well, so yeah, piston miner. If you're doing an architecture hook in Python, that is somewhat intentional, right? Like the goal was to make the performance better for those. If you were doing an entire PPC architecture in Python, it would be significantly slower. But architecture hooks are a little bit of a headache depending on what you want to do, but they do have that advantage that you can implement them more easily in Python. Although for most people nowadays, since all of our architectures are open source, we're just like, if you want to really do something, you can just clone it and modify it. Yeah. Cool. Well, I think we hit everything on my to-do list. We've got the new type changes, which again, hopefully we'll get out to you guys on dev soon. So you can fix up those structure member cross references, and those actually work. We played around with SCC, which I know was another one that had been requested. As a reminder, we've got our internship program. If you weren't here at the beginning of the stream, that we kicked off, and check our Twitter. We'll be linking to it as well after the stream is done. I like doing like the first thing live here because I like you all knowing that you're going to get a special treat ahead of everybody else if you tune in each week live. So we'll be putting that info out there. And again, as a reminder that our intro and our outro is still not been identified, and there's a prize there for people. So I think I'm about going to wrap it up. If you guys have any other questions or feedback. So Piston Miner, were you here when I was covering that on stream and showing it off? Sorry if I really should remember how long you've been commenting, but it's on a test branch right now. It basically just needs more internal testing and review. But I would like to get it out next week. Shouldn't be very long, I hope. Yeah. Okay. Yeah. So good. You already saw it then. Yeah, we'll see. I mean, it is a possibility it comes out sooner than that. It's just for big features, we like to have a couple set of eyes take a look at things and do some testing, and so that's one where we need somebody else to come and take a look at it. But yeah, no, it makes sense that was a top rated bug, right? Like it's a feature enhancement and it wasn't something we did well, but it's also a bug basically because the way how the cross references were just so broken before. You're right, like that was just a problem. So thank you for upvoting it if you did. That's the point, right? We're trying to do the things that y'all need the most soonest, and happy to have that. I think that'll be one of the nice features landing soon. So. Awesome, Piston Miner. Hopefully that does make everything easier for you. If anybody else has no other questions or feedback, I think we'll probably wrap it up here and be heading out. Oh, that's funny. I just saw the count up. Somebody just joined, I think, in the last couple of minutes. So unfortunately, you're here on the tail end of the stream, but you're welcome to scroll back and catch the rest of it. And if you refresh the YouTube page the second after the stream, I usually go back and I'll add timestamps so you can get to stuff more easily. But again, here's that final final output. Hey, Dutchy, welcome. Yeah, no worries. But I'm just for context, I'm trying to be really consistent about 5 p.m. start time Eastern every Friday. Although we'll see, my wife has been lobbying me to change it because it's not great for family stuff when I'm doing this till 7 if we wanted to do things Friday evening with the kids. But usually anywhere from an hour and a half to 2 hours is about the time I'm aiming for. So this was a good one. A couple of good things today. Definitely go check that out, and look forward to seeing y'all next week. If you have, and also this was one of the weeks I did not have a guest on stream, but I'm always looking for more. So if anybody is interested in hanging out, I mentioned earlier, love to have people chatting about primarily Binary Ninja plugins, but other reverse engineering topics are interesting too. And happy to have some more folks on. We've got a couple other people I think we're going to get lined up for you. We'll introduce you to a few more of the Vector 35 people as well. So thanks again for hanging out. Look forward to seeing everybody next week. Take care.